Welcome Math 7A Spring 2018 Exam 1 Solution Key. First of all, I want to warn you to ignore any of my little chicken scratch that you see along the page, the stuff that I did in pencil, very light, you can barely read it. Just ignore that. We're going to pretend it's not here. Question number 1. The graph of a function f is given. Use the graph to answer the question. Number 1, part A, is f of 3 positive or negative? Now we're looking here at the graph, and here's our work for part A. F of 3, by definition, is simply the y partner when x is equal to 3. So I look on the x-axis, 1, 2, 3, and then I have to find a point on the graph. It's down here. So I had to go below the y-axis. So f of 3 being the y partner, it's below the y-axis, so it's negative. It's actually negative 2 right here. But the issue is it positive or is it negative? That was the question, and the answer is that it is negative. Part B, for what number x is f of x, the y partner, greater than 0? Write your answer in interval form. Part B, we're looking for x values such that their y partners live above the x-axis. That's what it means when we say that f of x is greater than 0. It means the y partner is above the x-axis. So we just look at the x values. We're looking for the x values that have the y partners above the x-axis. Well, starting at -5, we have an x-axis above the we have a point above the x-axis, and it continues all the way until we get to x equals -1, -3. So from -5 to x equal -3, all of our y partners are above the x-axis. So that's the first part of our answer. And it includes -5 because that point specifically lives above the x-axis. It does not include, it excludes -3 because it does not live above the x-axis, it lives on the x-axis. That's why we have a round bracket here. And we continue through the graph. These are all below the x-axis. We start being above the x-axis as soon after we reach 1, 2, 3, approximately 3.5. At 3.5, we start having points above the x-axis, and that continues all the way to 5. So it doesn't actually include 3.5 because that's on the x-axis. It doesn't actually include 5 because that point is on the x-axis. So we put round brackets from 3.5 to 5, and that explains this answer. Part C, what is a domain of the function? Write your answer in interval form. Well, look at this. Let's try to clear some of these markings off. Okay, so they want to know what's a domain? That's what are all the x values in the graph. Well, the smallest x value begins at -5, and it actually includes -5. There's actually a point here. And it continues all the way to x equals +5, which also includes that number because there's actually a point, not an open circle. There's actually a point there. So our answer for all of the x values in the domain is everything down here, everything from -5 to 5, and it includes both of the endpoints. And that takes care of this answer. And scrolling down to what is the y-intercept? I'll clear some of the marks off again, and we'll talk about the y-intercept. The y-intercept is going to be part D. It's the ordered pair 0b. It's a point where the graph touches or crosses the y-axis, and that occurs here. And that is the ordered pair 0 for the x coordinate and down 1 to -3 for the y coordinate. And finally, part E. Part E was, for what value of x does the y partner, f of x, equal 1? We'll scroll down here. Well, let's see. There's a couple of them. There's a few of the x values for which the y partner equals positive 1. So I found positive 1 here on the y-axis. I drew a dotted line across it. Every point where that dotted line touches the graph, it represents a location of x values whose y partners are 1. So I estimated those values to be x equals negative 3 down here, x equals positive 4 here, let's see, 1, 2, 3, approximately, and x equals positive 5. I had to estimate, it wasn't precise, so if you were close, I gave you credit for that. Okay, we're going to move on to the next page, but don't leave, I will continue on this video. We are now in question number 2. Use a graph to find the intervals on which the function is increasing, decreasing, and constant. So I marked it up, but you can see as we travel uphill moving from left to right, that's considered increasing. And the x values for which we are increasing in this first interval occur between x equals negative 2 and x equals negative 1. That's why we have this open interval from negative 2 to negative 1. And then it increases again right here where x is equal to 1 all the way to x is equal to 2. So that's the open interval from 1 to 2. And then we union that together with the union symbol. Okay, let's clean off and find the intervals for which the function is decreasing. As we move from left to right, the function is going downhill from x equal negative 1 to x equal positive 1. And that's this open interval. And finally, they ask the interval where the function is constant. That would have been a straight line, a horizontal line. We have no horizontal line in this graph, so the answer is there are no intervals where the function is constant. Scrolling down to question number 3, the graph of a function f is given. Use the graph to answer the question. This is question number 3. So there's the graph, pretty complicated looking. It already has all the numbers on it, and the important numbers. And we're asked to find the numbers, if any, at which f, the function, the graph, has a local maximum, and where are the local maximum. Okay, now you understand that these graphs continue up and down because there's no point at the end. There's supposed to be an inferred arrow. So I'm looking for local maximum. I circled them too, the two of those in black. Those are my local maximum. Remember, they are the highest point in a neighborhood of x values to the right and left. Indeed, that's what we have in both of these cases. So those ordered pairs are actually given to me here. It's the ordered pair negative 8, 5, and the ordered pair 2.2, 3.9. Now, I just want to remind you that when they ask for the numbers at which the local max occurs, they're asking for the x values. When they ask you specifically to find the local max, they're asking for the y values. I gave them both by giving the answer as ordered pairs.